Welcome back, folks. We are now getting into Chapter 12. So Chapter 12.1 starts looking at visual displays of data, or data, depending how you want to pronounce it. So our basic concepts: information collected that is not organized is called raw data. If the data is numerical, then it is quantitative data. So think of it like a quantity. If it has a quantity, has a size to it, so that would be numerical data. If the data is non-numerical, then it is qualitative data. So it has a quality to it, but it doesn't necessarily have a size to it. So that's the way I like to keep them straight. So a couple of examples just to illustrate. If we have the number of kids in 9 families, so we have all these numerical values here, this would all be quantitative data. Whereas if we were asked for 3 makes of automobiles and we said Ford and Chevrolet and Dodge, obviously in the wrong order, but that would be qualitative data. So again, it doesn't have a size to it. Now, we like numerical data more, so we're going to focus more on that. First thing we can do with our data is sort it. So by sorting quantitative data in numerical order, it is easier to extract information about the data. So our number of kids in 9 families, if we sorted it, we can see that, oh, well, there's 2 families that have 1 child. There's 2 families that have 6 children. There's a family that has 8 children, and whew, I wouldn't want that food bill. But at any rate, that does help us kind of see things a little bit easier when it's sorted. So what are some other things we can do with data? Well, if we have a lot of data, we can start putting them into tables. Now, the fancy way of saying a table in statistics is a frequency distribution. So let's read what that's all about. A useful table to construct is a frequency distribution which contains each of the distinct values of the data and how many times they occur, which we would call the frequency. So each value has its own frequency associated with it. An optional component in the table is each value's relative frequency, which is a fraction or percentage, and I'm going to underline percentage because that's the direction we'd like to go, of the value's frequency over the total number of values in the data set. So we'll see how to do that pretty quickly using our handy dandy calculator. So let's try an example now. So a magazine identified the following 5 maintenance activities often performed by people as summer approaches. Too bad summer's almost gone, huh? First one though, prep the car for road trips. So we want to be ready for a road trip. Step 2, clean up the house or the apartment. 3, groom the garden. 4, exercise the body. 5, organize the wardrobe. So the following data are responses of 30 people who were asked on June 1st how many of the 5 activities they had accomplished. So we have all these numerical values in here from 0 to 5 and everything in between. So we're going to be doing a little flipping back and forth with this one. So we can see that our table, our blank table, will look something like this. So we have our values, our tallies, our frequencies, and our relative frequencies. Now the tally column is always going to be an optional column, but it's nice when you're counting a lot of different data values, so that way you can just kind of put a little hash mark for each time you see something that fits into that category. So the first thing we said though was that our values range from 0 to 5. So that's what we're going to start off with here. So we got 0, 1, 2, 3, 4, and 5. And so now the next part is the tedious part. We got to count all those instances of each of those and write them down in here. So we're going to go back to the other page and let's take a look and count. So if we start with our zeros, we can kind of see that we got 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 zeros. So let's flip back and write that down. And if we wanted to do our tallies to make it look pretty, we could do something like this: 1, 2, 3, 4, slash, 1, 2, 3, 4, slash. So there's our 10. All right, let's go back and do the ones. So the ones, we got 1, 2, 3, 4, 5, 6, 7. 7 ones. Okay, well, let's just keep going. I'm just going to put a little 7, a 1 with a 7, so I know. Let's do the 2s. 1, 2, 3, 4, 5, 6. So 2s, we have 6. 3s, we got 1, 2, 3, 4. And let's do the 4s. 4. We got a 1 of those, 2 of those, looks like just 2. And last but not least, our 5s. So we got 1, 5, and looks like that's it. So 7, 6, 4, 2, 1. Seven, 6, 4, 2, 1. And just to be complete, doesn't hurt to fill in your tallies. Now, how do we know we didn't miss any values? Well, let's go back and just verify, first of all, how many did we have? How many values in general? Well, we saw that there was 30 people. So there should be 30 numbers in total. We can check in our table by just adding up those frequencies. So if we look at those frequencies that we just wrote down and add those up, so what do we get? So we got 10, 17, 23, 27, 28, 29, 30. So we do end up with 30, so that's a good sign. So we probably did it right. Now, the relative frequency, remember, it said to take each individual frequency and divide by the total. So, and we want to get a percentage out of that. So let's see what we can do. So we had 10, and we know we have a total of 30. So if we divide that out, we get 0.3 repeating. And let's just round that to 1 decimal place once we change it to a percent. So 33.3%. Now, just so I don't mess it up, let's get our calculator out and do the rest. 7 divided by 30 is 23333. So 23.3%. 6 out of 30. Well, I think that might be a nice one, right? Looks like 0.2. So that's going to be 20%. Remember, move it 2 places. So 4 out of 30. Let's see. Looks like 0.133. And we got a couple more. So we'll round that to 6.7%. And last but not least, 1 out of 30. And we get 3.3% for that one. All right. Now, another question we can ask is, how do we know we did that right? Well, we have all these percentages. Hopefully we have all of the data, or 100% of the data. So let's add those up and just verify that we got all 100%. Now, because we rounded, it might be a little off, but let's just see how close we are. And look at that, 99.9%. And again, because we rounded, it's probably going to be a little off, but that's close enough in my book. So, all right. So that wraps up the first problem. We'll continue on and see how we can do other types of displays of this data in the next video. See you soon.